back. So what we're looking at today is 4.3, solving equations literally. So we're going to deal with more literal equations today. So don't think you're free from them yet. All right, so let's go ahead and jump on in. So what we're looking at here is solving inequalities. So we want to use the quality -9 is less than 2 to complete each row in the table. So they did an example for us. We're going to add 3 to both sides. So -9 plus 3 gives us -6, and 2 plus 3 gives us 5. Is the equality still true? Yes. All right, so for number 1, we're going to subtract 7 from both sides. So -9 minus 7. I'm just going to write what the actual solution is instead. So -9 minus 7 is going to give us a -16. Is less than 2 minus 7 is going to give us -5. Is -16 less than -5? Yes, this is true. All right, for number 2, add 15 to both sides. -9 plus 15 is going to give us 6. Is less than 2 plus 15 is 17. 6 less than, is 6 less than 17? Yes, so this is also true. All right, number 6, multiply both sides by -6. So -9 times -6 will give us a positive 54 is less than 2 times -6 is -12. Is 54 less than -12? No, this is false. So you guys will finish out these here in the middle, and number 7, all you're taking and doing, you always go back to this inequality up here. The -9 is less than 2, and you're going to do every one of these operations to it. Then for number 8, what operations, when performed on an inequality, reverse the inequality? Meaning, which ones do you find that are false? We already found one that was false, so we know if we multiply by a negative number, it's going to change the inequality or make the inequality no longer true. So what other operations will do the same? Okay, for number 9, this next section is all about literal equations. And note, it says show your work. Yes, I want you to show your work. I don't want the equations just wrote down. So for number 9, Q equals 25 pi h. So what we're taking and doing here is we want to get h by itself. So we're solving for specific variables. So notice, different variables are being solved for each time in here. Variable is your key word for this lesson. So to get the h by itself, what's happening between the 25 pi and h? They're all being multiplied. So to undo multiplication, we need to divide. So we divide by 25 pi, divide, by 25 pi. That cancels out. So we have Q over 25 pi equals h. There's our answer. We have now solved this for h. You are not going to get numbers for the majority of these. The only 2 that you're going to, well, there's 3 that you'll get actual solutions, just plain old numbers for. The rest of these you will not. For 10, notice the equation's fairly similar, but what happened? We got even more variables. So the equations in the left-hand column are the same as the equations in the right-hand column, except for the fact that the right-hand column has more variables in it. There's less numbers and more variables. So to solve this one, we're still solving for h. Now we have Q equals pi r squared h. So how do we get the h by itself? Well, what did we do over here? We divided by 25 pi. So here we're going to divide by pi r squared. So divide by pi r squared. So we have Q divided by pi r squared equals h. There's our solution. All right, the next one we're looking at is number 13. We're solving for z in this case. So we have a equals z plus 7 times 3. So in this case, what we want to take and do is get rid of this 3 first and foremost. So we can divide both sides by 3. Now, we could also take and distribute the 3 through. Either one will work. So there's different ways you can do this one by all means. So that'll cancel out. So now we have a over 3 equals z plus 7. So now we need to take and get rid of the 7. So I'm going to write this off to the side over here. A over 3 equals z plus 7. So we subtract to get rid of the 7. So we're going to end up with a over 3 minus 7 equals z. Do not put the a minus 7 all over 3. The only thing that's being divided by 3 is the a, not the 7. So be very careful with that, okay? All right, we're also doing 14. Notice they're very, very similar, except instead of having a 3, we have a w. So we're still solving for z. What was our first step over here? We divided by the number on the outside of the parentheses. So let's divide away our w. So we divide by w, divide by w. So we have a over w equals z plus 7. Now we subtract the 7. Same thing that we did on the left-hand side. We haven't done any operations differently. So a divided by w minus 7 equals z. So there's our solution. Like I said, very, very similar to what we did over here. The only thing that's different is the numbers, because one side has numbers, one side has variables. All right, and the last ones we're going to look at are 19. So we want to solve for x. So we have 3/4 times x minus 2 equals 12. So what we want to do here is get rid of this 3/4. To do that, we need to multiply by the reciprocal. So we're going to multiply by 4/3 to both sides. So this will cancel out. So now we have x minus 2 equals. Now we need to take 12 times 4, which is 48, and then divide it by 3, which is going to give us 16. So we end up with 16. Now, to get x by itself, we add the 2. So it's always opposite operations, remember. So 16 plus 2 is 18. So this is one of the ones you get an actual number answer for. So this one's 18. Now, we are also doing 20. What do you notice about 19 and 20? They're the same, except instead of having just minus 2, we have minus 2y. We threw another variable in there. So we still start at the same, though. We do everything the same. We're going to multiply by 4/3 to both sides. That cancels out. So we have x minus 2y equals 16. Now, same thing that we did over here. We had minus 2. We have minus 2y. We do the opposite operation. So we're going to add 2 here. We're going to add 2y here. It doesn't change the fact that we have the y attached to it. We can still add. So we're going to end up with x, sorry, too many crazy lines, x equals 16 plus 2y. There is our answer. Apologize for the random lines going through it. So this is solving these literal equations. The one on the left and the one on the right are related, so use the ones on the left to help you solve the ones on the right. And remember, your keyword is variable. All right, our next section, we are identifying x and y intercepts. So locate the x-intercept and the y-intercept in the table. All of your x-intercepts are going to be an x value, and your y value will be 0. So if you look, where's the y value 0? Here. And the x value is 2. So your x-intercept is 2, 0. For the y-intercept, it's when x is 0. So we go find 0 in the x column. And what's our y value? 4. So we have 0, 4. Do the same thing for 22 and 23. Now, on the graph, same thing, looking for x and y intercepts. Remember, this is our x-axis, this is our y-axis. So our x-intercept, it's crossing right here. So we're 1, 2, 3. So we're at 3, 0. Our y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, is up there at 9 because it's what's on the y-axis. So do the same thing over here. Find the point on the y-axis, that's your y-intercept. Find the point on your x-axis, that's your x-intercept. All right, the last section is solving each equation for x and providing the justifications. So we're going to look at 27. So we have negative 16 equals 3x minus 11. We want to get x by itself. So first thing we need to do is eliminate the 11. How do we do that? It's being added here, so we need to subtract it. So minus 11, so subtract. So negative 16 minus 11 is negative 27 equals 3x. Now how do we get the x by itself? Well, the 3 and x are being multiplied, so to undo multiplication, we divide. So we end up with x equals negative 27 divided by 3 is negative 9. So x equals negative 9, and we also use the division property here. All right, 29, we have an x on both sides, so we want to get those combined first and foremost, at least I like to. There's 4 different ways to start this though, so you can take your picks on how. I'm going to start by subtracting x, because it's positive over there, so subtract. So we have 5x plus 3 equals 18. Now we need to subtract the 3 from both sides. This cancels, so we have 5, if my marker will work, 5x equals, we're subtracting 3, so 15, so another subtract. And then we divide by 5, so x equals 3, and we have our division. So some of these are going to involve more steps than others. And the last one we're going to look at is 32. So we have x times b plus 7 equals 9. We have another literal equation. We want to get x by itself. Well, the x and the b plus 7 are being multiplied together. So we're going to, we're going to divide b plus 7 on both sides. So division. So we have x equals 9 over b plus 7. There's our answer. So literal equation. 31 is also a literal equation, but that one will be for you guys to solve. All right. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.